Hello, welcome back to Learn with Biju. In my 5 topics, I am going to discuss data modeling. In this session, let's see what is a data model, what are the types of data model, what is conceptual data model, logical data model, and physical data model, how are they being used, then advantages and disadvantages of a data model, then some of the tools being used for data modeling. So, first question, what is a data model? Data models are visual representations of an enterprise data elements and the connections between them. So we need to understand that data models are visual representations of an enterprise data elements. So the key is enterprise data elements and connections between them. Okay. So the connections and the data and the visual representation. So that is the data model. Okay, let's see how a data model can help an enterprise. Models support the development of effective information system by helping to define and structure data in the context of relevant business process. What is that model is supporting? Models support the development of effective information system by helping to define and structure data in the context of relevant business process. Models enable the business and the technical resources to collaboratively decide how data will be stored, accessed, shared, updated, and leveraged across organization. Data models play a key role in bringing together all segments of an enterprise, that is IT, business analyst, management, and others, to cooperatively design information system. That means data model plays a major role to bringing different segment of an enterprise. Then, by explicitly determining the structure of your data, these models support a variety of use cases, including database modeling, information system design, and process development in support of a consistent, clean exchange of data. Finally, it provides a clear picture of the base data and can be used by the database developers to create the physical database. So, if the data model is well prepared, the developer can use the data model to create the physical database by exporting them. So, this is of great help to any enterprise. So, let us look into different types of data model. As you see, there are 3 types of data model: conceptual data model, logical data model, physical data model. So depending on where you are in the data modeling process, you are likely to use one of them for sure. So conceptual data model, logical data model, and physical data model. So what is conceptual data model? This model is typically created by the business stakeholders and data architects. It's not created by a developer. The purpose is to organize, scope, and define business concept and rules. The conceptual data model is an organized view of the database concepts and their relationship. The purpose of creating a conceptual data model is to establish entities, their attributes, and their relationship. In this data model level, there is hardly any detail available on the actual database structure. But the 3 basic tenets of conceptual data models are entity, a real world thing, and attributes, characteristics or the properties of an entity, relationship, dependency or association between 2 entities. To show you an example of a conceptual data model, you imagine a customer and product. Customer and products are 2 entities. Customer number and name are attributes of the customer entity. Product name and price are attributes of product entity. Sale is the relationship between the customer and product. The conceptual data model known as domain models create a common vocabulary for all stakeholders by establishing basic concepts and scope. That's all. Let's move on to the logical data model. The logical data model is used to define the structure of data elements and to set relationships between them. Okay, so we in the conceptual we saw the entities, and the logical we are seeing it is defining the structure of the data element. For example, you see the time, date, date description, month description, year, week description. So the structure of the data element and setting the relationship between them. Now we have the product, we have sales, there is a relationship. We have sales and we have store. There is a relationship, right? So in the logical data model, we are defining the structure of data elements and setting the relationship between them. The logical data model adds further information to the conceptual data model elements. So the previous one we saw customer, we saw product. Now we have customer name and what is the type of the name. Then we have customer number. What is the type of the number? And some more details has come in, right? So the logical data model adds further information to the conceptual data model elements. The advantage of using a logical data model is to provide a foundation to form the base for the physical model. The modeling structure remains generic. At this data modeling level, no primary or secondary key is defined. So, in which level could be the primary and secondary key is defined? It should be in physical, right? At this data model level, you need to verify and adjust the connector details that were set earlier for relationship. You know, in the conceptual, we told there is entity, there is attributes, and there is relationship. But in the logical model, we need to verify if the relationship set there is right or not. Okay, so you understand what is conceptual data model and what is a logical data model. Now let's move on to the physical data model. This data model describes how the system will be implemented using a specific DBMS system. This data model describes how the system will be implemented using a specific DBMS system. Database management system, that is a DBMS system. This model is typically created by DBA and developers. The purpose is actual implementation of the database. The physical data model describes a database specific implementation of the data model. So who is creating the conceptual data model? As I said, it is a stakeholders or it is the architects. But who is creating physical data model? It is created by the DBA and the developers. And this purpose is actual implementation of the database. The physical data model describes a database specific implementation of the data model. Cool? Let's move on. Physical data model offers database abstraction and helps generate the schema. This is because of the richness of metadata offered by the physical data model. We are very close to DB, right, in this stage. The physical data model also helps in visualizing database structure by replicating database column keys, constraints, indexes, triggers, and other DBMS features. So here you are seeing that. So in our visual, we are already seeing that it is already showing which is the primary key, which is the unique key, etc. So far we have seen conceptual, logical, and physical model. So what are the advantages? The main goal of a design data model is to make certain that data objects offered by functional team are represented accurately. It's a kind of validation. The data model should be detailed enough to be used for building the physical database. So as I already said, the physical data model give the abstraction and we can extract the schema. In that case, the data model should be detailed enough to be used for building the physical database. The information in the data model can be used for defining the relationship between tables, primary and foreign keys, and stored procedures. And data model helps business to communicate the within and across organization. Data model helps to documents data mapping in ETL process. Helps to recognize correct source of data to populate the model. So as we have some advantages, there are also some disadvantages for the data model. To develop data model, one should know physical data stored characteristics. This is a navigation system produces complex application development and management. Thus, it requires a knowledge of the biographical truth. Even smaller change made in structure requires modification in the entire application. There is no set data manipulation language in DBMS. There are numerous commercial and open source computer aided software engineering solutions are widely used today, including multiple data modeling, diagramming, and visualization tools. Here are some of the examples. Erwin Data Modeler is a data modeling tool based on the integration definition for information modeling, data modeling language that now supports other notations methodologies, including a dimensional approach. Enterprise Architect is a visual modeling and design tool that supports the modeling of enterprise information system and architectures, as well as software applications and databases. It is based on object-oriented language and standards. Enterprise Architect is a visual modeling and design tool that supports the modeling of enterprise information systems and architectures as well as software application on databases. It is based on object-oriented languages and standards. ER Studio is a database design software that is compatible with several of today's most popular database management systems. It supports both relational and dimensional data modeling. Free data modeling tools include open source solutions such as Open Model Sphere. What are my takeaways? Data modeling is the process of developing data model for the data to be stored in a database. Data models ensure consistency in naming conventions, default values, semantics, security while ensuring quality of the data. Data model structure helps to define the relational tables, primary and foreign keys, and stored procedures. There are three types of conceptual, logical, and physical data models. The main aim of conceptual model is to establish the entities, attributes, and their relationship. Logical data model defines the structure of the data elements and set the relationship between them. A physical data model describes the database. Hope it was useful. If you like the video, please like, share, and subscribe.